So how do we represent a complex number? Well, first let's revisit the idea of how do we represent a real number. We represent a real number by using a real number line right here. So we could represent the number 1 as just this point on the real number line. Now, how do we represent a complex number? Well, we do so in a plane. Because our complex number is composed of our A component and our B component, we need to create a system. Here we use x as the real axis and y as our imaginary axis. The reason why is because now if we take the A part, which will correspond with our x, our point z equals to 2 plus 3i can now be plotted. 2 here and 3 here. And so we get this complex number. Now, an important concept that we have developed is the modulus of a point. So modulus of z is equal to just basically the square root of 2 squared plus 3 squared here in our example. We're taking a and we're squaring that. We're taking b and we're squaring that. Also same thing as taking x, squaring it, y, squaring it, summing those, and taking the square root of that. So that's modulus. Now, when we talk about complex functions later on, so f of z representing a complex function, we need to understand that because representing a complex number requires a 2D plane, and since we are limited in a 3D world, we can't really draw out a complex function and graph a complex function, but we can use some technique called linear mapping, in which if we take a set S here, for example, all the points here, all the z points in this set will produce an image here, and we denote the image as S with a prime, like that.